Okay. Starting now. So the first thing I want to present the LoRa Alliance. This webinar is brought to you by the LoRa Alliance. Since 2015, the LoRa Alliance has been developing the LoRaWAN standard to where it stands today. One of the most successful IoT standards, particularly for LPWAN and anything battery powered. It's now recognized by IETF as an official international standard, so you can actually specify LoRaWAN in your tenders. Today, we will have 3 speakers focusing on smart metering and more specifically focusing on the DLMS technology. DLMS is one of the most popular metering standards. It's also an official standard, therefore specified in many countries as the protocol to use for water metering, gas metering, or electricity metering. And today we will have Toufann, who is the CTO of the DLMS UA. He will drive us through all the details of the standards, the recent profiles, and everything. And we have also Pascal Bourguignon from Taurus Metering. Pascal is really an expert of head-end systems, and he has really probably the best experience worldwide on actually using DLMS over LoRaWAN and protocols like SCHC, so he will explain some of his experience. So the agenda today I will present a little introduction and also present some large references which today run DLMS over LoRaWAN. Then Toufann will really present the standardization process behind DLMS and the recent progress there, more particularly when it regards the profiles, the specific profiles for water metering, for example. Recently, the overall certification of DLMS over LoRaWAN has also progressed a lot, and Toufann will present the golden device that was developed for this. Then Pascal will go to really very practical presentation of DLMS over LoRaWAN. He has huge experience on this, so you will have examples, the actual frames, how to put together the head-end system, and presenting a little bit what Taurus has been doing, which is really, really impressive already over LoRaWAN. I will move on by presenting the SCHC standard, which is really a very, very technical standard, a sort of intermediate layer, but solving all the problems that exist when you want to map and run DLMS over LoRaWAN. So let's start with this intro first. You're all familiar with TCP/IP. The DLMS protocol has been specified on several transport layers, but by far TCP/IP is the most popular. The problem with TCP/IP is that really it's been designed for more faster networks, wired networks. If you take the TCP header alone, it's 20 bytes. If you're adding the IPv4 addresses, it's twice 4 bytes. If you are using IPv6, you would get to twice 16 bytes. And the largest payload you can transfer over LoRaWAN is on the order of magnitude of 50 bytes. So obviously, you have a problem without even doing anything on top of TCP/IP, just the TCP/IP protocol itself. And of course, DLMS itself carries a lot of information, and it can be several hundred bytes. Most of the time, it's way more efficient than this. Often we're hearing that DLMS is big, fat, and inefficient. It's not the case at all. Actually, in most cases, it's extremely efficient. But yeah, it can span more than 50 bytes. So as a result of all this, it's not possible, unfortunately, to use IP directly as a transport layer over LoRaWAN. You need to do something. And the magic is on the next slide, please. The magic is a protocol called SCHC, which we'll present in details. It stands for Static Context Header Compression. It's missing the F for fragmentation, and fragmentation is probably the most important feature of DLMS. If you have something that's too big to carry on a single LoRaWAN packet, you can chop it in little parts, and SCHC will take care of that, and also the reassembly on the other side. Of course, LoRaWAN is not a reliable network. You will lose packets on the way. You need to be able to find out which have been lost, how to retransmit, and SCHC takes care of all this. Now, the overall layering, if you go to the next slide, the overall layering looks like this. So at the physical layer, you get LoRaWAN. At the top layer, you get the application process, the DLMS stack, and really the existing metering process on the DLMS stack believe they're running on an IP network. They are spoofed in a sense to believe that this is a regular IP network. What's in between doing all the magic is SCHC. And SCHC is really acting, if you look at it with the eyes of an IP engineer, it will appear as an IP tunnel. So you are literally tunneling IP packets over LoRaWAN. Let's move on to the next slide. So in many, why would you like to use DLMS over LoRaWAN? There are other standards that can carry DLMS. One of the most popular is power line communication, PLC here, G3 PLC being one of the most popular. But you do run into issues with power line communication is designed for relatively dense deployments, and also you need to have very, very clean transmission lines. If you get issued with parasitic capacitors or some unstable topologies in the electric network, in some places you will run into issues with PLC. Cellular runs really fine, but you don't have cellular everywhere, and you might not have reliable cellular communications where you want to deploy the actual DLMS meters. So LoRaWAN comes sometimes as the best option for the whole network if you don't have anything else that's available around. LoRaWAN is very efficient when you get very sparse deployments, with few meters on very large surfaces. And also LoRaWAN is excellent as a backup technology. You might be running the bulk of your meters over PLC or over cellular, but you have still a few meters that do not connect properly, can be 5% of the meters, in which case LoRaWAN is great because it's running on unlicensed technology, and therefore you can deploy your own, as a utility, your own LPWAN network where you need it, only for those meters that cannot connect to other technologies. As a result, LoRaWAN really comes as a very efficient technology from the standpoint of total cost of ownership. This is a small computation that was done for an EMEA country for about 500,000 meters. And in many other places, you will see Italy, you will see Ivory Coast later on. LoRaWAN comes out as a very, very good technology for deployment. So that was the intro, and I hope you're very curious now about DLMS. But before transitioning to the deep dive, this is all live. This is not just theory. There is already a huge project, for example, in Italy by Italgas, their Nimbus project. This is the new meter that you have here. They already have tens of thousands of meters that are running exactly the way we described, DLMS over SCHC over LoRaWAN, and it will expand starting mid this year to 8 million meters. You can watch the video by scanning the QR code. And with that, I'm passing over to Toufann for a presentation of DLMS.
Thank you. And now I would like to present the DLMS User Association. Some key figures to start with. DLMS represents today, excluding China, 63% of all the installed smart meters worldwide. That amounts to almost 300 million installed devices to date. Additionally to that, we've certified over 2,000 products, have more than 300 members as of today, and almost 30 years of experience. The DLMS User Association is a non-profit organization. Essentially, our main mission is to standardize metrologically relevant data model and formats, and to certify products, such as to guarantee a complete compatibility and interoperability of products independently from the manufacturers. In order to do that, we collaborate with national and international standardization organizations, as well as with telecommunication bodies. Just a short overview of our current liaison agreements. As you can see on the top, we have many SDOs, IC, ANSI, Senelec, and many others, as well as I mentioned for Kobe in Brazil, CEPRI in China. And on the lower part, you can see the telecommunication liaisons that we have. So obviously, we have a liaison today with the LoRa Alliance, but also with others, as we basically develop further profiles for telecommunication technologies, and I'll get back to that later on. So what is actually DLMS all about? Well, DLMS is, as I mentioned previously, a data model and a data format meant for data exchange. It is telecommunication agnostic, and it's meant for legally relevant information. So understand by that, for instance, information linked with billing. It's an object-oriented model, which of course fulfills all the requirements in terms of data privacy and cybersecurity, and is standardized and certified by the DLMS User Association. That's an essential pillar of our activities, and I will cover it more in depth in the following slides. So our activities basically rely on 4 main pillars. The first one is collaboration with standard organizations such as IC, Senelec, but also with organizations standardizing telecommunication technologies. Other than that, we standardize the application layer, so the DLMS application layer and the COSEM object model. These are the activities that are run within the user association by our membership. And we also, very importantly, specify and release GCPs. GCP stands for Generic Companion Profiles, and that's an essential brick in the journey towards compatibility. I'll be giving a bit more details about GCPs very shortly. Last but not least, our certification program. DLMS has in place a very rigorous qualification program for both compliance and for compatibility. And this is an essential chain in guaranteeing device compatibility in a manufacturer agnostic manner. So if we look a little bit more into what actually this whole thing is about, well, this is a schematic view of the DLMS COSEM stack over LoRaWAN. So you can see on the top of the picture the physical and the MAC layers. These layers are standardized by the LoRa Alliance. Then next you have transport layers, namely SCHC, IP, and UDP. These are standardized by other telecommunication bodies, in this case by IETF. And then we come to the DLMS layers. We have the DLMS COSEM IP wrapper, and we have the DLMS application layer. These form what we call internally to DLMS the Green Book. You can see on the left-hand side, there is also a telecommunication profile. In this case, for LoRa, it's called the LPWAN profile. It is also standardized by the DLMS User Association, and it's also part of our Green Book. Essentially, this is to provide the right parameters in order to configure the telecommunication layers. On top of it, and that's what you see on the lower part of the picture, we have the COSEM object-oriented data model, and that is what we call the Blue Book within DLMS jargon. Now, compliance certification actually is about verifying that the implementation of the Green and the Blue Book are done accordingly to our standards. But that's not sufficient to guarantee compatibility between devices. So that is where we add an additional layer, which we call the generic companion profile. The generic companion profile is a subset of the data module. It's targeted to specific industry segments. So think of it as, for instance, a segment for AC electricity smart meters. And it basically consists in specific parameterization of objects and models and data that can guarantee that the implementation done by all the manufacturers will always be identical, hence guarantee that we can have compatibility and interoperability across the devices. Now, our liaison agreements also play a fundamental role. Firstly, the liaisons with standard organizations such as IEC, Senelec, ANSI, and others. Basically, this is to allow that our specifications are brought into various bodies that are nationally or internationally recognized, but also to ensure that some of the country-specific or region-specific requirements can be added into our generic specifications. Next, the liaisons with the telecommunication organizations. They basically guarantee that if there are changes within the telecommunication technologies, or if there are changes within the DLMS COSAM stack, basically the other party gets informed of it ahead of time in order to be able to update the specifications and guarantee a full compatibility at all times. In here, you can see an overview of the complete DLMS COSAM stack. So on the upper right corner, you find LoRa. We have a number of other telecommunication technologies that we currently support, but this is by no means static. So in the future, as new technologies emerge, as others get discontinued, this is brought to be updated. And the DLMS User Association maintains at all times this mapping. So if you are interested in adding your technologies and getting them supported by DLMS COSAM, you can basically reach out to us and we can further discuss that. Moving forward onto the certification, we actually have a two-step approach. As I referred to previously, compliance certification is done against our books, and that's the first step of the process. And then compatibility certification is done against the generic companion profile, and that's the second step. Let's look a little bit more in detail. So essentially, certification for compliance is verification that the implementation done by the manufacturers follow our colored books, and it is done using the DLMS test tool. So essentially, it's often seen as a self-certification. It can be done on-prem, and our members can upload their test reports directly on the DLMS website. It's worth mentioning, though, that this will not be available for LoRa. The reason is that for cloud-based golden environments, going through an accredited test lab is a mandatory step. The second step in the certification process is certification for compatibility, and it can only be started once the certification for compliance has been successfully completed. The second step, so compatibility, is always done within an accredited test lab because we always do the tests within a certified golden environment, and that is to guarantee that the actual device works in its own native telecommunication technology, and it is done in a controlled environment. In here, I also would like to mention that when it comes to LoRaWAN, we are currently qualifying devices, and we expect to be able to start certifications in Q3 of 2025. Just a few words, we have an upcoming Water Smart Meter GCP that's going to be published, hopefully within Q2 of 2025. You can see here the main use cases that are covered within this specification. It is currently not yet available, but as soon as it gets published, all our members will be able to access it. Of course, I would mention that the Water Smart Meter GCP includes the LoRaWAN telecommunication profile. So essentially, what does DLMS do? Well, DLMS standardizes the data model and the application layer to ensure metrologically relevant data exchange. It does it in a way as to guarantee vendor agnostic compatibility. This is done through specifications that are called generic companion profiles. And very importantly, it is done, or it is ensured through our qualification processes, both for compliance and for compatibility. It's also worth mentioning that aside from the water GCP that I just mentioned about, DLMS is currently working on further companion profiles, such as for the gas and multi-utility markets, and several of them will already include support for LoRaWAN technologies. Here are some additional information if you're interested to have a look into our website. We have a couple of white papers as well that are published, and you can also look into the already released AC, ESM, AC electricity smart meter generic companion profile. Have a look at the release notes to get a better idea of what the content is all about. Thank you very much. And now over to you, Pascal.
Thanks. Good afternoon, everyone. My name is Pascal Bourguignon, and I am the CTO of Taurus Metering. At Taurus Metering, we specialize in remote meter management solutions, leveraging advanced communication technologies to optimize innovating smart metering use cases. We have extensive expertise in metering protocols such as DLMS and wireless M-bus. You can see in this slide our core team and expertise as well, and our meter management solution called Vision. Today, I am excited to share with you how DLMS over LoRaWAN combined with technologies like SCHC is enabling cost-effective, secure, and future-proof smart metering solutions. One of the key strengths of this approach is its DLMS over IP architecture, which ensures seamless integration, flexibility, and scalability. DLMS COSEM is probably the most advanced and used metering protocol. That means that DLMS is not only kind of a natural language for a head-on system, but also that the head-on system already knows how to manage most of the possible metering use cases, such as connection, disconnection, tariffs, demand management, prepayments, including with STS tokens. DLMS COSEM over LoRaWAN operates within a standard IP framework that makes it compatible with existing head-on systems without requiring complex adaptations. Globally, the head-on system just sees an IP-connected device that is either always connected as a Class C device or connected from time to time for Class A devices. This brings several advantages. First, DLMS messages are transmitted over IP, allowing direct communication with the head-on system, just like in conventional smart metering setups that you can already find today, especially for electricity. Also, there is no need for communication technology complex integration. The head-on system processes the data as if it were a standard DLMS COSEM exchange over a traditional network. And finally, the LoRaWAN network server management is simplified, so utility can focus on data processing and analytics rather than only network operation that are managed by specialists like Actility. Thanks to SCHC compression, the IP, UDP, and DLMS COSEM layers are efficiently managed, ensuring that even with LPWAN constrained bandwidth, we maintain full DLMS functionalities while optimizing power consumption. Therefore, this solution fits not only electricity, but also battery-operated devices such as water or gas meters. And contrary to common misconceptions, DLMS COSEM isn't perfectly compatible with low-throughput networks like LoRaWAN. Actually, SCHC allows probably stronger optimization than any other protocols today. So how SCHC makes daily DLMS select IP and non-optimized DLMS comes with cost that will make it difficult to use with the constrained bandwidth and limited payload size of LoRaWAN. And this is where SCHC helps. SCHC acts as an intelligent compression mechanism, optimizing DLMS messages for transmissions. It works by reducing dramatically the size of IP and UDP headers, making the messages significantly lighter on the network. Also, it eliminates the redundant information in the payload, and that ensures that only the essential data is transmitted. But it maintains the full DLMS compatibility, meaning all standard DLMS custom functionalities remain intact. You can see in this slide how it happens from the meter to the head-on system. And obviously the same would happen also on the other way. You have the meter on one side and the head-on system on the other side. And both handle full DLMS over IP package. That's the full stack you can see on both sides with IP, UDP, wrapper, and the DLMS application layer. However, CHC in between is applying compression and decompression rules in such a way that LoRaWAN is eventually carrying only the useful payload. And this approach ensures that battery-operated meters can function efficiently for years, minimizing energy consumption, and LoRaWAN remains a viable solution for advanced metering infrastructure, even with the limited throughput. So utility can leverage existing based system on DLMS without major modifications, ensuring seamless integration. On top of that, CHC brings fragmentation solution. So when a message can't fit in one LoRaWAN payload, it will be cut in smaller chunks. Again, that's fully transparent for the head-on system that receive or transmits always the full packets. So let's see an example of the typical data frame. This is actually a real example for an electricity meter, but the same would apply for water or gas meters, and possibly for any other kind of sensors. On the left, you can see a full DLMS frame over IP from the IP header to each single field of the payload. And on the right, you can see the same frame optimized with CHC. In this one, we get rid of all the gray part, and it will actually transmit over the air only the chunks that are still in black. And you can see that the full frame in this example is 160 bytes, but after the CHC compression, we only transmit 67 bytes over the air. And so that's a huge gain. That's about 60% gain. That means it's definitely worth spending some time on fine-tuning those rules for each specific requirements. And the very nice point is that any non-optimized messages, that means messages for which we won't have a specific rule, will fall in the default rule. That can be the command you want to send to the meter only once in a while. It won't be optimized, but that's not an issue because at the end of the day, it won't make much traffic in the lifetime of the meter. And on the other hand, you can still access to the whole DLMS data model of your meter. So let's see one of our main use case, which is prepayment. Traditionally, prepaid metering required a physical access to the meter, and it's even more difficult for water meter because it can't easily provide a local keyboard or local access, and it requires also some interaction with a local vendor. However, with DLMS and LoRaWAN, we enable a fully digital 24/7 remote prepayment cycle. And this is accessible directly from a smartphone application, mobile money, USSD codes, or any other digital payment platforms. So how does it work? The customer initiates a credit purchase through their preferred method, as I said, mobile application, USSD, web portal, whatever. And the utility system updates the meter balance remotely via LoRaWAN. And the meter enforces the prepayment rules, ensuring that consumption is limited to the available balance. And that's a key point. That's the meter that actually manages the credit balance and not the system. And also at the end of the day, alert and notification are sent directly to the customer when their credit is running low. That's to avoid an unexpected service interruption. So by combining DLMS for secure credit management and LoRaWAN for real-time communication, and also STS for a standard prepayment process, this solution makes prepaid metering more accessible, reliable, and scalable. So this slide presents a pilot project in Ivory Coast. Actually, this is a real project running now. So in this project, we have a smart water meter using DLMS over LoRaWAN. And this deployment has demonstrated its ability to support prepayment and tariff management for water. And the same project is also running for electricity. One of the main objectives of the utility leading this project is to enhance customer experience by offering new services. And really, for prepayment, smart metering and digitalization definitely makes sense. And I won't get into details, but you can see in the map the actual status of some meters in the field. Basically, here we can see the meters that are running out of credit, are about to run out of credits. And the meters are monitored continuously, so the utility is able to support the end customer. The add-on system provides many indicators, so to the utility, like end of credit estimated time, also the consistency of water consumed compared to the volume booked by the customers. However, most of the time, credit purchase and application to the meter are transparent and performed by the customer without any operation from the utility. So to conclude, we really think that the combination of DLMS, LoRaWAN, and SCHC represents a major step forward in smart metering for new use cases, but also it makes well-known use cases more efficient. So I hope that this presentation has demonstrated how DLMS COSEM provides a standardized, secure, and widely adopted metering protocol, ensuring compatibility and interoperability. LoRaWAN offers a cost-effective, long-range, and low-power communication solution, and that makes it ideal for smart grid applications. And in between these, SCHC compression optimizes data transmission, allowing full DLMS functionality over the constraints network. So with the benefits of this technology, we can provide a comprehensive solution with a fully featured head-on system, state-of-the-art security, and specifically real meter supervision. And utility can reduce operational cost and improve service delivery to the customer. Thank you for your attention, and hand over to Olivier.
Okay, let's have a deep dive on the magic behind everything that you've seen so far, the static header compression protocol. First of all, let us start with a little bit of history. SCHC is not the only compression and segmentation protocol that has been designed by the IETF. If you use mobile phones, behind the scenes, you get a protocol called robust header compression, but not really, adapted for anything that's really, really low bandwidth. Then there was the 6LoWPAN, which was in the around 2007, which was introduced together with the 802.15.4 networks. You might be familiar with Zigbee. For the first time, the idea came that you really needed to do something to shrink, in a way, IPv6 packets to be transmitted over such radio networks. And actually, I don't know if you know this, but this is the way LoRaWAN started. Before it was called LoRaWAN. I'm one of the engineers that was behind the LoRaWAN. We started to do 6LoWPAN over LoRa. But then really it was still too big. There were still too many fields, and we simplified, and this ended up to be LoRaWAN. Well, really, it's the same story with SCHC. When looking at IP compression, engineers in 2019 thought it's really possible to do a better job. Knowing everything that we know about IoT now, we should be able to compress the IPv6 or v4, UDP, and even application layer headers for co-op, for example, in a much, much better way. So that became SCHC, and it's really possible to reduce the overhead to just a few bytes. So the dream behind this, illustrated on that next slide, is to achieve with IP what IP achieved for general networks many years ago. If you remember, at some point, there was ATM, token ring, Ethernet, all this was a big battle. And as a developer, you didn't know what to use, really. And then IP came as a sort of universal adaptation layer. And you could build any application on top of TCP or UDP. It would run over any low layer, because you just see IP. SCHC is exactly the same dream, if you want, on top of any LPWAN. You can be running LoRaWAN, you can be running Sigfox, you can be running NB-IoT, or any proprietary or future LPWANs. If you design your application to run over IP through SCHC, it will run, and you don't need to rewrite your code. So that's the dream, and let's see now how this is achieved. On the next slide. So in terms of standards, there are a few standards that you need to be aware of. RFC, request for comment 8724, is specifying sort of abstract compression and fragmentation mechanism, but independent of any specific low layer. And then for LoRaWAN, you need to read request for comment 9011, which is giving the details that are specific for LoRaWAN. And I will be a little bit more detailed after this on which details are they. There are more standards around IETF. For example, if you want to compress the co-op application layer, then you can read this 8824, but it's unrelated to metering or LoRaWAN. There are other standardization bodies that work specifically for DLMS. The IEC is one of the most important ones, and the other document that you need to read if you want to build the DLMS over IP over LoRaWAN application is 62056.8.12, which was established through DLMS liaison with the LoRa Alliance. And there is also technical documents 10 and 6, the report number 6, which were delivered through the liaison of LoRa Alliance. Together, all these documents specify everything that you need to know to implement DLMS over LoRaWAN. On the next slide, I'm going to go a little bit into the details. So the communication is between a sender and a recipient. In the memory of the sender and in the memory of the recipient, there is a context. And the context really says, take that field, and that field is static, replace it possibly by nothing, because it's always there, it's always the same. Or take this field, and in this field, there is only that part that's variable. For example, the UDP port part in my application is variable. Remove everything, but keep the UDP port. From these rules, from this context, the sender will achieve compression. So really remove all the unnecessary information that repeats itself and is always the same. Keep only the variable parts. And finally, a very important layer. After all this work, it can be too big for the maximum transmission size, payload size of LoRaWAN. In that case, you fragment and you will need to reassemble at the recipient side. So this is overall the way SCHC works. There are several ways to do the fragmentation. If you move on to the next slide. So this is very detailed. I'm not going to go too much into details, but this is an example of what a profile is used for. In the original RFC, there are several ways of hacking the packets, to make sure that they can be retransmitted and you can detect errors. In the LoRaWAN profile, the default specified for uplinks is called hack on error. So essentially, you fragment the payload in a window of little chunks, and the hack will be sent at the end of the window. And for downlinks, the mechanism is the hack always. That's what needs to be used for LoRaWAN. And the details are spec'd out in the RFC. Can move on the next one. So overall, as discussed earlier in the introduction, once you've put in place this removal of information on the sender side and fragmentation, it is reassembled by the recipient side as a perfectly valid IP network. So really, if you look at it from the IP network engineer eyes, it's a tunnel. You don't need to really care what's happening after the tunnel. It's not your business. In this case, it is LoRaWAN. But really what you have is an end-to-end IP network. Can move to the next slide. So let's look at it from a practical point of view. So these are screenshots that are taken from the ThinkPark platform SCHC server. Between the LNS and the SCHC server, the connection is the same as between an LNS and an application server. So at the LNS level, you're in the LoRaWAN world. You really don't know what IP is. The only thing you know is that the payloads you're receiving from the device, they need to be processed by a specific application server. And this is the IP core SCHC server in that case. So on the LNS side, this is the screen on the left. You just specify that this is an HTTP connection and you specify the IP address of the SCHC server. And at the SCHC server side, you create, so this is specific, of course, for this SCHC server. You create a source description that will declare essentially the LNS and that the IP address of the LNS is valid on the SCHC server side. Can move on for the next part. Okay, this part is it's important to understand why it's needed. Say that you have a SaaS service, so your LNS is shared between multiple gateways, and the SCHC server is also hosted in a SaaS. When the packets are reassembled by the SCHC server, they can potentially belong to several IP networks, and these IP networks, they could be overlapping. For example, if you decide to use private IP addresses for your meters, so they would be, for example, in a 10.x.x.x or the equivalent in IPv6. Once you decompress them, you might have several colliding IP addresses between networks. So in order to avoid this, the SCHC server is not transmitting the IP packets directly over the internet. It is tunneling these packets inside the VPN. So these packets, they can be delivered to the head-end system. And if there are several head-end systems, it will deliver the packets to the right head-end system. So it resolves this issue of potentially overlapping IP addresses over the entire LoRaWAN network. So for this, you can see that on the SCHC server, when you need to configure the IP network, you will declare obviously the range of IP addresses and your classic IP network details, but also you will be able to specify a VPN link. And that's because you need to deliver all these reassembled packets over a VPN tunnel. Can move on to the next slide. Okay. This is the details on the SCHC rules. So if you see the screen on the left, you will see a big list, towards the bottom of the screen. And these are all the rules that are applied in sequence, which elements to compress and how to compress them. This is what's called the SCHC template, which is part of a device profile. So all this is done only once when you configured your network. You apply a specific device profile to your existing DLMS meter, and from there on, the SCHC server will be able to fully decompress all the packets received from the meter and reinject them to your head-end system as normal IP packets carrying DLMS. So your head-end system doesn't see a difference. It will really believe that it's talking to a real IP network. Now, doing this, you need to be smart. For example, if your head-end system is using random ports, whenever you send a request to the meter, you're using a different port, then it will not be possible to compress this port, and you will need to carry this port all the way to the meter and back. It's a waste. So when you do DLMS over LoRaWAN, you need to be smart and you need to use DLMS in a way that can be compressed better. For example, you should use fixed ports, whenever you send the request out, fixed source port, so it can be completely compressed, replaced by nothing, which is the best way to compress some information. Can move on to the next. Okay, now I'm just going to describe a little bit the toolbox that are being provided in the ThinkPark solution. First of all, there is SDK. The SDK is something that you can embed to any LoRaWAN device. As we'll see, it's provided as open source. Everybody can use it, and the source is open, and it's free. Then you get the server side, the SCHC gateway. It will reverse everything that the SCHC SDK compressed, and vice versa. When the SCHC gateway is compressing commands, the SDK will take care of decompressing. So with these two, you can run any IP application over LoRaWAN, provided, of course, that it's small enough pieces of data. You can't do video this way. Unfortunately, it won't help. You can move to the next slide. So if you're curious about the open source SCHC SDK, we partnered with the universities, so we made our source code completely available to Lab SCHC, which is in partnership with IMT Atlantic University. You can access the whole code at the URL that appears here on screen. It's a fully industrial stack. it has been embedded in real meters. It's memory size optimized. It can run over bare metal, or it can run over any RTOS. Multiple processors are available, and it's fully functional, including most options of the SCHC protocol. So really, don't spend your time re-implementing your own. Just use this one. It's probably all you need. Can move on to the server side. So this server is available primarily as SaaS. If you want to test it, it's available over the free service, which we call the ThinkPark Community. You can just create your own profile, connect your gateways, connect your devices, and contact us. So we will instantiate an instance of the SCHC server. You will need to tell us which is your head-end system, what IP address it has, and we will give you a small VPN client so you can terminate the tunnel on your side. And your head-end system, again, will just see that it receives IP frames. So no change on your head-end system. Everything is provided as SaaS. For large deployments, of course, it's also possible to deploy it on-premise. This is what we call OCP on this slide. Can move on to the next slide. When it comes to certifying DLMS over LoRaWAN, this was presented by Toufann. You will need an environment, to be able to interconnect with the DLMS UA test tool. And even before you do this, you will probably need an environment to test that DLMS can be decompressed and that your head-end system or head-end system emulator can receive the packets. The kit for this, which we call the golden toolkit for DLMS, is available on our marketplace. You can scan this QR code. It will provide everything that's needed. It will provide a test DLMS client, a test DLMS head-end system emulator, of course, the VPN tunnel, the SCHC, and access to the SCHC server in the cloud. And when you're ready, you need to contact the DLMS UA and subscribe to test session with an accredited lab. And the accredited lab test tool will replace the head-end system. And after this, it will torture test your meter. And after this, it will be fully certified by the DLMS UA. Can move to the next slide. Okay. Finally, although this is really very sophisticated technology overall, and it's used today to perform not only standard metering, but also very complex metering scenarios like prepaid metering. Really the most advanced scenarios of DLMS, they're already running over DLMS on top of LoRaWAN networks. Today, many brands of meters already support these stacks. So first of all, it's available if you want to run it today as an end user. And if you're a meter vendor, this is really an add-on that I recommend that you will look at, because in many cases, it will complement existing power line networks or existing cellular networks. LoRaWAN isn't licensed, so in any place where you cannot connect meters easily, you just deploy your own gateway, your own LoRaWAN network, and you solve the problems by yourself without having to wait for the cellular operator to densify the network, or without scratching your head why that PLC line doesn't work. It's fine, just switch to radio and solve the problem. Thank you. And with that, I think we will transition to the QA session. So if you have any questions, now is the time. Thanks a lot for your attention. So we'll pick the questions that were already written. We have 8 right now. So the first one is asking about which commands are available for devices. So Actually, it's very simple. All of them are available because, as we just explained, the SCHC and LoRaWAN layer, they really just compress the IP packets. They don't try to understand, interpret, or filter what is there. Now, that being said, although you can send every command, you need to be aware of the limitations of LoRaWAN in terms of uplinks and downlinks. LoRaWAN can accept many uplinks, but the downlinks are really very limited. There is a single gateway depending on where you deploy your network with a limited duty cycle to send commands to devices. So, for example, you should design your DLMS profile in a way that really makes maximum usage of the push. So you have DLMS primitives to configure push objects, and you should make really maximum use of this, as opposed to constantly doing a get to get the object. So very often when people are used to IP meters using cellular, they are not really conscious of the limitation of the radio, so they do constant pulls without realizing that it's very, very inefficient. So it's much better to replace this with a push. But besides this, which is really just profiling, tuning DLMS in a way that adapts to the capabilities of the radio, there is no limitation per se. And as I think also was explained by Pascal, you can have some primitives that are extremely well compressed, but you can still send the others. They will fall to the default rule. They will use a little bit more bandwidth, but if you do it from time to time, like for troubleshooting, it's not a problem. Using one port for all communication. So the second question, actually in the webinar, I was emphasizing that yes, prefer to use a single port. For example, for source ports, if you just open a socket on a Linux computer, or actually any computer, without specifying the source port, it will be selected for you by the operating system dynamically. And usually it's not really a problem, except if you want to compress the source port to completely remove it, which is the best compression, just remove it. Of course, at the decompression side, we cannot guess what port it is if it's a dynamic port. So in case you use a dynamic port as the source port of your packets, you will need to transmit that port in the protocol itself. If you use two ports, the best compression will be to use one bit. Bit 0 is mapped to port A and bit 1 is mapped to port B. But if you have a choice, really, it's easiest to just use one port as the source port, and this way you will get better compression. Pascal, I think you can handle the question on Ivory Coast because you're really best positioned for that.
Yeah, thank you, Olivier. Yes, regarding the Ivory Coast, the main use case is really, as we explained in one slide, the prepayment. And the reason the prepayment is a use case that is ideal for DLMS is because in DLMS you have all the objects to manage the credits, the STS tokens, and so on. So it makes really sense to use DLMS for prepayment, and especially for new use cases with water meters. Let's know if there is another question after that. Did you answer about the question about security?
Yeah, you can take this, or Toufann, if you want.
Yeah, maybe I can take this one, Olivier. So I think there is a need to make a distinction. So the security suites, they are actually the security levels that are at the DLMS application layer, and that's different from the securities that you can have at transport layer. So you have two possibilities. Usually it's best practice, so we recommend to use security suites 0.1 at the application layer, because that guarantees or that provides end-to-end encryption and security for the packets that are being transmitted. But of course, this can have an impact on the size of the payload. So it depends really on the type of configurations. And then, of course, you can do the setup of the security layers, either for LoRaWAN or for the other IP layers separately.
Then we have, where is the SCHC protocol running? Is it on the meter or another device? On the instances that I've seen, the SCHC compression is directly in the meter. Although, of course, it could be separate. You could have some appliance that is interrogating the meter or terminating DLMS over IP and then running SCHC separately. But in all meters that I came across, the SCHC is implemented directly in the meter. And if you're looking for a SCHC stack for a meter, you can get this, as was explained in the webinar, from IMT Atlantic University. I think there was a QR code or a link in my webinar. It's essentially the source code of Aclio, which is the startup behind much of the SCHC protocol, which is industrial code, and it was transferred as open source to this university. So you can make use of it. It's an industrial code, so really no problem to use in a real meter. The following question is just yeah, for clarification, really SCHC on the meter side, if you have access to IP, so as soon as you get access to the IP frame, then you can implement SCHC. So again, it can be all within the same modem, together with the LoRaWAN stack, or between the LoRaWAN stack and the IP stack of the meter. So in theory, you could locate it in different modules, because really the separation corresponds to the protocol separation layers. On the gateway side, in the implementations, typically the head-end systems, they are not aware of SCHC. The head-end system really communicates only IP. So the way it is connected together, the SCHC server will appear as an application server to the LoRa network server. So the LoRa network server receives the LoRa frames, transmits the LoRa frames to the SCHC server using the network server API. So usually it is MQTT or HTTP, something like this. It's non-IP at this stage, because LoRaWAN packets are not IP packets. The SCHC gateway receives the payload and interprets it as a compressed IP packet, decompresses it, and then it can transmit it directly to the head-end system. If you're using only one IP network on your entire LoRaWAN network, it's simple. You just decompress and transmit maybe over Ethernet directly to the head-end system. In the implementations I'm aware of, there are multiple IP networks that are multiplexed on the LoRa network. Therefore, you can have overlapping IP addresses. So the SCHC gateway is not sending the IP packet directly to the head-end system. It is sending it over a tunnel. Maybe it will be familiar for those of you who use SIM cards. On SIM cards, you can have a private APN, private access points. This is the equivalent on LoRaWAN side. You get your own private APN. Within that APN, you can get your own IP network, and these packets are delivered to you over a VPN. I think the next question was probably the same. So yeah, same chain of decompressing the SCHC packet into an IP packet, and then the head-end system just sees the IP packet. Maybe I don't know, Toufann, if you want to take the question from Jasmine on does DLMS require two-way communication?
Yeah. So typically, yes, it would require two-way communication, but it doesn't have to be symmetrical. So as also was mentioned, I think by you, Olivier, before, you can use rather push if you want to send data from a device to a head-end system. Though at some point, some of the functionalities will still require to get acknowledgements back or to receive some information from the head-end system. So it cannot be just one way, if that's the question. So there will be still a need for a way to send the information down to the device.
The next two questions. So for meter vendors who want to add this, the best step to get started. So again, what I'm aware of in terms of the most mature embedded implementation available, this is the one that was open source to SCHC Lab. So it's called SCHC Lab. It's run by a university called IMT. The code originated from an industrial implementation. They will not charge you for the code. It's free. It's open source. If you want to get specific support from them, then probably they will charge. So this is on the embedded side in the meter. For the core network server, the one we presented is the SCHC server from ThinkPark. We call it ThinkPark X IP Core. This one exists in the test implementation, so you can contact us. There is a free LoRaWAN network server. You can Google ThinkPark community. You can create your own LoRaWAN network server there, and then contact us to get access to the SCHC server. You will get the IP packets over a VPN. We can provide you with a VPN termination code. You can run it in a container or on a Raspberry Pi. And so all this is available. And in our experience, the most difficult to get is usually the hidden system. And for this, I'm sure you can contact to Pascal, because very often it's complicated because some meter vendors have their own hidden system, and some insist to charge you millions of dollars to just get started with it. So it's a bit tough, but I think with Taurus Metering, you get a very good option.
Thank you, Lee.
Some tech overhead on overhead. Well, if you're talking about developer overhead, of course you need an embedded developer to integrate the stack within the meter. But again, it's been all pre-coded, right? So expect an API that really looks like a socket. So if your code is designed to communicate with an IP socket, you have an API very, very similar to opening a TCP or UDP socket. Then you will actually be talking to the virtual IP stack of the DLMS toolkit for the embedded meter. And then that DLMS toolkit already has hooks to the underlying LoRaWAN stack. So you probably need a couple of months of embedded developer to get it to run smoothly, but it doesn't go beyond this. On the server side, really, it's very, very easy because there is nothing to code. The server is doing all the work for you, and there is no modification at all in the hidden system. Be prepared, however, to spend some time on profiling DLMS, as we said before. Very often when we get on projects, you find DLMS meters that have been configured in a way that is very verbose, pulling data, things like this. So you need to reconfigure them. DLMS is a very, very smart protocol. You get clocks, you get scheduled push, lots of things, all the way to prepaid support for prepaid encrypted tokens, as Pascal said. But often it's underused. It's used in a very primitive way, just reading what you want. So it needs to be configured in what it can do best. So you need a little bit of engineering on this as well, but it's not coding, it's really just profiling.
Yeah, and clearly, that's the nice point of SCHC. It provides some room to optimize the data transmission. So for sure, the optimization needs some work, but it can really change the quantity of data you have to transmit over for sure.
Now the question from Petri Schmidt, which commands embeddings are available for devices? So all of them, right? No limitations introduced by SCHC. API integration docs, you will find this on the documentation portal so it's docs.thinkpark.com. You can go to the IP core, and there you get all the API integration docs on the core network server side. If you're looking for API documentation for the client stack, you will get this from the SCHC open source project. Metric options, all interval options, all in theory, but need to be reasonable, right? This is not LTE connection. So typically LoRaWAN will make sense if you send an uplink every half hour, every hour, something like this. If your network is dense enough, it could be every couple minutes, but it's not something that's going to scale for public networks. It's going to something that you can do for demand response for private networks. So you need to be aware, of course, of the limitations of LoRaWAN. But typically for the public networks that we are aware of, it's working fine in the uplink. It's really in the downlink that you need to be careful to not create overcapacity on the command side. Can the SCHC rules be reconfigured in real time? I mean, in the end device as a COSM object? Maybe that's for you, Toufann. I think in theory, probably yes. Now I'm not aware that any meter is doing it yet. I don't know.
Yeah, I'm not 100% sure, but that's typically what the LPWAN profile. So we spoke about previously the 62056 what was it, 8-5, if I remember correctly, or -8-8 maybe. Well, anyway, that's typically what this profile should be allowing to do, but I am not 100% sure if it is actually
I can confirm to you.
today.
Can confirm to you. It depends on the implementation.
Okay, right.
It's technically possible that the meter allows this.
So and that's exactly what these communication profiles are meant for.
Exactly.
So that's to allow such things to be done.
Okay. And I know there is ongoing work within the IETF to also have SCHC level mechanisms to synchronize the rules. But right now, I think it's safe to say that in most real implementations, the rules they are set, really when you design the network.
Yeah.
So in the I spoke previously about the generic companion profiles. So typically, when we would specify a generic companion profile, we specify also which communication technologies are supported, and we would specify also how the proper implementation should be done. And so typically in this case, we could standardize the fact that we want this feature to be enabled. And if it is enabled, how it should be done so that we have a plug and play or a complete compatibility between different devices with respect to head-end systems. So I think that is one of the interesting aspects, and definitely here, as we work out on the generic companion profiles, as we improve them or as we release new ones, these are items that are relevant and that can be included.
One port for everything. What are the best practices to differentiate? Well, in the DLMS protocol level itself, you can differentiate. So if you have a full head-end system that will be decoding the DLMS for the head-end system, there is no ambiguity. It doesn't need the port. Now, if you use the ports and you need to use the port in your implementation, I don't know, maybe because it's a different server for sending commands and server for receiving, use a fixed one. Therefore, that port will be compressed really only by 1 bit. Just make sure there is as little variable information as possible, because whatever is variable and cannot be predicted cannot be compressed. So if every time you see a field in your message, you need to really be sure that you need it. And if you absolutely need a port, then use 2 ports. It can be compressed to 1 bit. The next one by Remy, I think only you can answer, Toufann. It's about certification.
Yeah, so correct. So today it's only possible to certify a DLMS server. So DLMS server is typically what you would have in a meter and not a client. But this is something that we are currently working on. So at this point, we don't have yet a date when it will be possible, but we are planning on making also client certifications possible in the future.
How big is the Telegram header after SCHC? So really not much, because ideally, if you respect the sort of good practices, limiting the dynamic information, so your IP addresses are fixed, so a given meter will always have the same IP, it will always use the same port. What SCHC does, I know it sounds a bit stupid when I say it, but it just removes the information. You know, most of the time, the easiest way to compress is remove, so you end up with having just a couple bytes of overhead. So it's really very, very minimal. And most of this overhead is actually linked to the windowing mechanism for segmentation, because what we keep focusing on compression for SCHC, and so SCHC essentially removes pretty much the entire IP header in most cases, but you still need to manage segmentation, because in many cases you will get packets that are a little bit bigger than the about 50 bytes allowed by LoRaWAN. So you have a little bit of overhead to manage this, but it's really extremely efficient. So you're talking about really, it's bytes, and it's that level. Who would be the perfect customer for adding DLMS to their solution? It's hard to define the perfect customer, but I think the customers that Pascal Bourguignon has
I would say all customers are perfect.
They're really perfect, because they need prepaid, they need a very, very sophisticated metering protocol with prepaid and things like this. It's very big areas. So I don't know what you think, how ideal they are, Pascal.
Yeah, I said, in my opinion, all customers are perfect. So there is no question. No, not kidding. The interest to go to DLMS is offering answers to a lot of use cases. So as soon as you want to introduce new use cases, so I talked about prepayment, but also we can think about tarification, demand response, and many use cases. The good thing with DLMS is you have plenty of object, of method. You can quite easily address your needs. So I guess if you want to do a smart thing, you're a good customer for DLMS.
Thanks, Pascal. I think that's I would also want to add two further comments to this one. The first is that we not only do the specifications and the standards, but we also certify. I think that is very, very important, because it gives the guarantee that the implementations are done properly and that they will indeed be interoperable in the field. That's the first thing. The second thing is that we are also now giving a big push, and there is a lot of work ongoing in the user association, but also within the different liaisons DLMS has with IEC, for instance, around edge data exchange. And today there is an installed base of devices that speak DLMS that actually allow some information coming from DSOs to be exchanged at the edge. Now I'm really thinking about electricity. I'm really thinking about grid curtailment problematics. And these existing infrastructure can be leveraged, and it allows such devices as, for instance, customer energy managers to receive from the DSOs directly information when there is a need to curtail, and this without having to install anything additional. So there is also a quite big interest in terms of interoperability and extension of existing infrastructures to serve new purposes to use DLMS.
Maybe a quick comment. It really is a perfect tool to avoid vendor lock-in. It's very, very frequent in the metering world, unfortunately, that people say they comply to standard. Trust me, deploy 50,000 meters, it's all open, it's great. But when after deploying 50,000 meters, you want to select another vendor, you will discover that everything is actually not quite the standard and doesn't work. So we face this a lot in the SCHC world. I can tell you that between the first implementations that are it's SCHC, it works end-to-end, and it's really SCHC, there is a lot of work. And with the DLMS association, it's easier, because either it's certified or it's not. It's very binary. And if it is certified, you can really be absolutely certain that you can swap any other meter vendor, so it's a good thing to avoid vendor lock-in. So Nick comments that it sounds it's only for large customers. For sure, if you're going to buy 200,000 meters, avoiding vendor lock-in is great. But also, I think that as Pascal was saying, with DLMS, you get the toolbox, which has the answers from many years of experience. So very often what we see is projects that start, it looks simple. You know, sometimes it's a very proprietary meter because the problem looks simple and let's start simple. But after the fact, you find problems that can be not as sophisticated as prepaid. But for example, I want to get my metering record at 4 p.m. every day. Sounds simple, right? But you also need randomization. You also need lots of things. And you find yourself reinventing the wheel when DLMS already had something completely ready that you just needed to configure to use. So DLMS meters are not more expensive than normal meters. They're only better designed. That's my my take on it.
I would even go one step further, Olivier. I think they might even be cheaper at some point because they are all standardized. So at some point, you just have a set of use cases. The manufacturers, they are not tailoring their solution for your needs. So they just produce base configurations, which all have the standard use cases. Of course, nothing prevents them. They can always add on some nice features that would then provide, let's say, innovative functionalities that might not be available. But the base functionalities, the ones that everyone will be using, so that serves 80% of the needs, they are built in there. So you don't have to respecify, you don't have to retest either. Because if you are a small utility and you buy a custom designed meter, then you have to certify it yourself. You have to do the full test campaign, and that costs a lot. So there is a really interest in leveraging what is available as standard. And then, of course, nothing prevents, as I mentioned, to add some additional features that might be specific to your needs or that might add some functionalities that are not available in the standard use case definitions.
And a quick comment on the head-end system. It's true that some head-end system vendors, you know, they come essentially from the vendor lock-in time. So it can happen that you do get these monster systems that would cost millions and millions, and they're indeed scary. But that's probably when you need to place a phone call to Pascal and change your mind. Okay, I think
Thank you.
reached the end. No, we have actually questions keep coming. Email addresses to connect with LoRaWAN. Okay. Sorry, I'm not sure how to type in the webinar, but I think you can. I think for me it's just first name dot last name at actility.com. And maybe you can ask the LoRa Alliance for emails. Otherwise, for the SCHC lab, if you type SCHC.lab in Google, you will get to it. I think the LoRa Alliance will be able to provide the contacts later on. Sorry again, I'm not sure how to type in the chat. It is higher upfront cost for integration, no vendor lock-in, and long-term lower cost. The last two, I'm sure, and I'm not even sure for the first one. Again, I'm not sure you get higher upfront cost. I think the meters will cost the same. You do need to spend something on the head-end system. I think you have very competitive options there in the DLMS world. So don't take it for granted. You know, as often, many proprietary solutions, they fight the standard by saying, don't call these guys, don't use the standard because it's very expensive. It's a Rolls-Royce. Get a quote. Don't get intimidated by this. Okay. I think we're done. So I want to thank the LoRa Alliance a lot for the opportunity to present this very technical topic. And we did have a very technical audience. And also I want to thank Toufann for giving some of his time and expertise from the DLMS UA, and Pascal for the field experience, really great experience on very complex use cases of DLMS and head-end systems. Thanks, everyone.
And thank you too.
Thank you. Thank you, Olivier.
Bye.
Bye.